Oh, okay. And just to make sure you guys can only see this like doc right here, right? The one that says midterm review and with classes. Okay. So to start off, um, I'm basically just gonna first go through the actual midterm review itself, like the study guide that Fox provided, and then from there provide a couple of examples, and then from there, um, I'll try and note like certain things to keep in mind when taking the exams in regards to each section. So this is a, I hope that gives a predictable rundown of what's like what I'm about to do. So the first thing um, that is asked on this study guide is what's encapsulation. Basically, encapsulation is the act of like organizing your code. So you don't want all your code just like willy-nilly, like easily accessible, which is why you have things like classes and private variables. And so not only is it like organized, but you can protect data. So it's not so accessible to be modified. You need getter and setter methods to do those instead of just like being able to do that within the code, with any outside code. So that's the biggest thing with encapsulation. Almost see encapsulation as like a room that you store all this like information in, all this stuff in. And when you want to get that stuff, you need to like have a code. And when you want to like specifically augment that stuff, you have another code. Like when you want to get that stuff, that's your getter methods. When you want to set that stuff, that's your like modify that stuff, that's your setter methods, and so on. So here's like a little example of like what encapsulation would look like. So you have your class car, you have a private variable, which you don't have to do this, but keep in mind classes are just default private. So like let's say you want to keep the speed of private variable. So it's not super directly accessible to outside of the car class. And now in your public, this is where you can get your getter and setter methods, aka your accessor and your mutator methods and functions. You guys have seen this before for sure, like with your labs and such. Also, by the way, and during any point, you guys want to ask questions, like please feel free to speak up or ask in chat. So that's the biggest thing with encapsulation. A part of classes, you also have a constructor, which is like a special kind of function that initializes objects, which basically means like they it makes sure they're there um, when they're created. And it has the same name as a class, it just doesn't have any kind of return. So this is an example of a constructor. You guys have definitely seen these before. Um, This is a big thing to remember. What is the name of the pointer of the invoking object? The special pointer is called this. You guys have obviously seen this before, but I think it could be asked in a way that might be a little, I don't know, confusing. So just make sure when if you're asked, like, what is the name of an invoking object in a class function, it's always going to be this no matter what. Unless like you get some example code and it's like otherwise specified for whatever reason, but it's always gonna be this. Um, oh, and also of course, like the name of a function, the function that like gets called when an object falls out of scope is the destructor. So when an object falls out of scope, that basically means it's no longer needed by the program. So your object is basically just like negligible. It's like it's just taking up space. Yeah, to answer your question, the this pointer is just this and then pointing to like the answer the question in chat. The this pointer is just literally yeah. Um, for any questions regarding like I guess little things like that, you will just like see on the in the multiple choice because all of it's multiple choice. The only thing that isn't multiple choice is we actually only talk about this because I talked about it before I started recording. For the exam, you're gonna get all multiple choice questions except you are gonna get some open response. But when I say that, that makes it sound like, oh, you're writing a bunch of code. No, you're just writing like maybe a string of numbers that is like auto graded. Um, it's not you're not writing like an entire class function or an entire class. Like that's not happening. Something to keep in mind with that though, with writing like this, you'll probably just like write like a string of integers or so. Something to keep in mind with that is really think to yourself, what is this actually outputting? Is there spaces in between? Is there commas in between? Is there nothing in between? Like keep in mind those little things because I oftentimes find that students think code will output, I don't know, like if they think it's going to put output one, two, three, they'll put one space, two space, three. And that unfortunately just would be counted as wrong because if there's no C out, um, I don't know, space, like C out one space, C out, oh, yeah, you get what I'm saying. Like, if you have, I'm sorry. This is not going to output because there's no spaces here. It's just going to output that. So keep that in mind. I see that as a common mistake made. So just be aware of that is the biggest thing. So to get back to what I was saying about the destructor. So your destructor is the function that's automatically called when an object falls out of scope. When an object is no longer needed in your program, it just gets destroyed. Just to save space, it's efficient. This is a part of the big three. So here's an example of what a destructor would look like. I know you guys know this, but just making sure that everyone knows. So your destructor is always going to have like this little squiggle line, and it's going to have the name of the class and with no return type. And it's just you can do some what's it called? Like print debugging to make sure like it's actually getting destroyed if like that's what you want to do in your future coding. So to clarify all of it. Yeah, all open-ended questions are just writing the output of the code without multiple choice. Yeah, that's exactly what it is. You're you're not like writing a new block of code. You're literally just writing like a string of numbers if that's what it is. Like that's it. It's nothing crazy. Which is great. I think that can make the exam a lot more approachable. But know that because it is set up that way, that this exam by no means is like some easy give. You do have to study, I think. You still have to try and you still have to pay attention because I think it can be, you can end up losing a lot of points on this exam by not paying attention to little things, which I will try and point out those things as I go through this review. So, what's an accessor? That's your getter functions. So, example, like if you want to get speed, this is going to get a privatized member without actually changing it. And the mutator is your setter functions. That's what I was talking about earlier. It's going to get a privatized variable and actually change it. So the public and private keywords are basically just intended to categorize if the members underneath of it are accessible from outside of the class or only accessible from within the class. So if it's private, which classes are default private, structs are default public. So for example, like this car class, I could technically just not have this private here and it would just automatically privatize it. But I just do that. I just put it there so it's a little easier to understand, but know that like classes are automatically private. Um, and this means you can only access this variable from within the class car. You can't access it from outside of it. But with public, you can access um, this member right here, this setter function from outside of the class. So that's something to keep in mind. But yeah, structs are automatically private. I mean, structs are automatically public, and classes are automatically private. So, and once they declare that, anything underneath of it will be like, for example, right here, when I declare public in this class, everything underneath public will be public, period. Unless I declare private again, which I don't even know if I would throw an error actually. So Don't just like keep it like in two separate spots. Nothing too crazy. So next is const. Const is basically a keyword in C++ that makes sure a variable or function or just object in C++ stays the same. It is not modifiable. So the way you can pass a constant variable is you're going to put it not before the variable name, like right here. Oh, like right here. You're not going to put it right here. You're going to put it in front of the data type, like in front of int. So you can't put, like you can't do this. It's not gonna pass through right. You got to do this. Put it in front. The way you pass constant parameters is the same way, except it's within the parameter itself. So for right here, you have const in front of, not in front of the variable name, but in front of the data type, and it's within the parameters itself. So that this is what keeps the parameters constant, not what's in the necessarily what's in the function itself, or the not what's like, well, not the function itself, I guess, but rather just the parameter. And then when you want to uh, protect a class function from modifying the this, so keep that in mind when you want to make this constant. Constant will protect the this pointer. Like when you make a class function constant, you are protecting this keyword. So keep that in mind. So here's a clear example of it here. So you're not going to have const, and unlike the other examples, you're not going to have const in front of the data type or the variable name, but rather in front of the return. So like basically in between the function name and the return parameters, like these squiggly brackets. So this makes this member function constant, which protects this pointer. Here are examples, like when keeping in mind with a constant pointer. When you're pointing to a constant value, you're going to put const in front of the variable. No, that's right, the data type. When you're making a pointer constant, you're going to put const in front of the variable name, so pointer in this case. And then when you're making a constant pointer to a constant, to another constant, you put const in front of the data type and in front of the variable name. That's a little much, but it's just, I guess, something to keep in mind. But this isn't like super, super, super ultra important. So memory allocation for this exam, I will note, is pretty important. So please make sure to pay attention to that and to know your stuff on that. Okay, so the biggest thing to keep in mind with memory allocation is that it will always, like dynamically allocated memory is on the heap, period. It is nowhere else. It is not on the stack. It is not some other place in memory. The new keyword allocates memory on the heap. So that's a big thing. Here's an example of that. And also keep in mind, even though memory allocation does use pointers, not all pointers do refer to memory allocated on the heap. Like you can have a pointer that's just pointing to something on the stack. It doesn't make it, just because it's a pointer doesn't. The best way we can put it is everything dynamically allocated will have a pointer, but not everything that's a pointer will be dynamically allocated. So please keep that in mind. Delete, of course, just frees up allocated memory, the memory that you allocated with the do keyword. So an example with the previous, like if you have int p and you want to delete that, you just do delete p. And also another thing to keep in mind is if you have an array, you will always use brackets. You cannot just do delete this. If you try and call this and then you want to deallocate it, you can't do this. This is not going to work. It's going to throw an error and it's not going to work as you intended. You have to use the brackets with an array, but only with an array. basically another th and of course, again, like you guys have practice with this with your labs, but knowing how these really work in and out is what's gonna help you get as many points as you can on the exam. So with memory leaks, that's when memory that is allocated with the new keyword is not freed by delete. So for example, we got the same guy from before, this int p, but we haven't deleted him, even though we don't need him. So it's just memory being used. So we could get a memory leak. Um, uh, Also another thing to keep in mind, with is the way to get the actual like data of a pointer. I guess we could talk about this when I get to pointers, but I'll talk about it now. When you want to actually get the access of like the memory address of a pointer, you have to dereference it. So that's just something to keep in mind. You can't just like call it. You do have to dereference it. Um, so we got templates. Here, I'll actually talk a little more about memory allocation just to make sure I go over. Um, the way you would dynamically allocate any memory is just by using the new keyword. That's that's always just going to be how it is. So keep that in mind. Um, Also, once you delete a pointer of the dynamically allocated memory, you don't have to do anything with it out after. Doesn't matter. It's already deleted. Um, and also dynamically, the reason why memory leaks are important to keep in mind is you dynamically allocated memory will last until it's deleted. It won't just go, oh, well, I'm not needed anymore. I'm just gonna leave. Like it will stay there until you delete it. And also, like you only delete it when your program no longer needs it. So if your program, like let's say, I don't know, you dynamically allocated a iterator variable for whatever reason, and like the iteration's done. Like it's done iterating through how many it needed to do. You just delete the iterator variable, but like you don't delete it in the middle of it iterating through your loop, of course. You only delete it when it's no longer needed for whatever you're making. Um, so yeah. Also, know that every time the new keyword is used, you're also going to use the delete keyword. So as many times as you use new, you will use delete as in general. That will just always happen. Um, and that means not just like how many times on how many lines of code it was called. It means how many times through the program is it used. So if it's running through a loop and you run through it, this new keyword 4 times. You just because the new keyword is only on one line, it doesn't mean you're using the you're gonna only use delete once. You're gonna use delete 4 times. Um, Also just like know that like we do delete dynamically allocated memory, so that we can continue to have memory for other parts of our code when we use it in the future. Um, we also may not know like the actual amount that we're taking up. So you want to make sure you keep deleting it just so you're not taking up space that you may not know like you may need later. Even if like, I don't know, let's say like your dynamically allocated memory only takes up so much space. You want to make sure that you're still trying to keep as much as open as possible to prevent any kind of overflow that could happen on the heap, which that'd be funny. Um, so that's one of the biggest things. Um, Also, with being able to understand like leaks and stuff, also understand um like let's say your code uses X amount of space when allocating memory and you don't delete it and your program uses that space 4 times, your if you don't delete it, then you have 4x amount 4x like space times the space that has been leaked. Sorry, that took me a long time to say. So like let's say I don't know, here. So let's say you have some function, I don't know. Um let's say you have some function, it's like int p equals new int like, like new. I'm just gonna say new. And let's say you use like some for loop and you I don't know, call this you call p again, like call p again. You have and let's say like p takes up x space. So since we haven't deleted this properly, this space properly, we know that it runs through this for loop 4 times. We know that it's going to take up, it's going to leak for x times amount of space. So just keep that in mind when trying to identify memory leaks. So to move on to templates, basically templates are meant for just like generic programming, so that it's easier to work with different data types. Um, so here's an example of a template right here, just a very basic one. Um, um, the biggest thing to keep in mind with templates is just that they are a tool that is used and they are not split into source and header files. That's an important note. Um, Also, keep in mind, another thing to keep in mind, this is not related to templates, but huge note. When looking at blocks of code, like it'll ask you like, what's the output of this code? And it'll be, I don't know, void something. Let's say you got a variable int referenced 1 int referenced 2 and not referenced 3. This third parameter, since it's not called the same way as parameter 1 and 2, it is not going to be behaved the same way. So keep in mind little things like that is going to affect the expected output. So it's like keeping in mind like little details like that when looking at code, really paying attention to those details that will really help you score well, catch all those points on the exam. So stacking the heap, like I said, any new memory that gets allocated is always on the heap, and variables are always created on the stack. So an important, something that's important to keep in mind with this is any variable that's created is put on the stack, including variables like your iterator and your for loops. So like I don't know, let's say you have like some loop. Hold on. int 5 equals 5. Okay, that's one var on stack. Int 2 second var on stack. 4 int I equals 0. Even though this is within it, like this is just our iterator, it's still made on the stack. So, like int less than 5. Int equals 0. I did this out of order, but you're gonna, like, let's say you have like add equals 2 plus 5. Return, return. Make this. Oh, wait, I didn't make that a function. Never mind. Point is, make sure to keep in mind that anything, any variable created within functions will be allocated on the stack, including things like the iterator, because I think that's an easy thing to forget. Oh, and a super important thing about Stack Overflow. So Stack Overflow will only ever be caused when you try and access more memory on the stack than what is available. You can do certain things like recursion, like right here, to cause a Stack Overflow, but recursion itself doesn't inherently cause a Stack Overflow. That just doesn't. Like we use recursion all the time and it doesn't inherently cause Stack Overflow. It's when we have infinite recursion. Which can cause Stack Overflow. And that is because if a recursion tries to access more memory that's on the stack than what is available, then that will cause a Stack Overflow. So keep that in mind. Because I remember that was a bit of an issue when that quiz was going around. So it's a little thing to keep an, I guess, like mess up on. But yeah, biggest thing, the only thing that will ever cause a Stack Overflow is when too much memory on the stack, when you try and access more memory on the stack than what is available. And that can be done by like using recursion, but recursion itself doesn't inherently cause it. But if you have like like let's say a question answer that asks like, oh, what could cause Stack Overflow? And it brings up, I don't know, if it brings up like, oh, like you use infinite recursion, that would be, yes, that'd be a reason to cause Stack Overflow. Because that infinite recursion is trying to access more memory on the stack than what will be available. Always trying to understand the why. Like if you see like a question answer, really ask yourself why. Because recursion isn't why a Stack Overflow can happen. It's when recursion tries to access more memory on the stack than what's available. I know I keep saying that, and I know it's probably like being a dead horse, but I feel like that's a really important thing to remember. So big three. Biggest thing about the big three is if it needs one of them, it's gonna need all three of them, period. It's just not, that's a non-negotiable. Um, Also your big three are, of course, your destructor, copy constructor, and your assignment operator. And here's what they look like. So this is what a typical constructor will just look like. A copy constructor will look like this. Your destructor, I mentioned this earlier, will just have this little squiggle guy, no return. Well, no parameter. I'm sorry, that's what I meant. But also no return. Your copy constructor does have a parameter of a class object. And your copy assignment, that a lot of people tend to get the copy constructor and the copy assignment operator confused. Just really keep in mind that the copy assignment operator has operator equals in front of it. That will always be the case. So I think that's a big thing to remember. Um, and that they will always have this kind of format, just was Google, class object, and operator and class object. So, mm, so just being able to like understand, like, let's say a variable was, um, like, I don't know, like say X, like let's say X was assigned to be, um, your assignment operator. If you're calling that at the end of a class and it's asking like, okay, what's being called right now? You're gonna say, oh, the assignment operator. So that's something to keep in mind. Also, the big three only gets implemented if there's dynamically allocated memory. Like that's the only time it needs to be there. It doesn't need to be there otherwise. So unless you see that new keyword, unless it's there, you don't need it there. You don't need your big three there. Um, so yeah. Um, so yeah, with the big three, the biggest thing is being able to recognize what the big three look like, if they're being called, and ultimately when you need them, which is only when you're have dynamically allocated memory. Otherwise, you don't need it. Like you can have it there, it's just not needed. um, Also, this is not really related. It's kind of related. Um, Something to keep in mind is when member functions are if different kind of operator functions, member functions are called, that'd be known as operator overloading. So I'm trying to think how to explain this. If you see like operator just used a lot and in multiple different ways, that is a way of utilizing operator overloading. Okay, so next subject. So follow, you guys have seen this before, of course. You got if stream, off stream, F stream. You know, here are examples like what processes can we use to rewrite data from a file. We can use off stream, for example. And here's more specific examples of each one being used. So you got off stream to write to a file, A stream to read, and F stream to read and write. Pretty pretty to the point. Um, Something to keep in mind is here. If one of y'all could answer like this would be great. But what do you guys remember what when you have like a CSV file, the comma in a CSV file, what is that called? What is the thing that, yes, it's called the delimiter. Okay, that's good. So yeah, whether it's a comma or a slash, that character that is used to separate all those different pieces of data is called a delimiter. It's usually commas because we usually use CSV files, like at least in this class. So, but yeah, they are always called delimiters. Um, and then pointers. So you guys have seen this before. um, this is this is what a regular integer variable would look like, and this is what a pointer would look like. when it's pointing to that piece of data. Well, more, sorry, when it's pointing to that address, which then you would dereference to get the data, which would be 5. Um, a null pointer is just making sure that when you do a pointer, it's at least pointing to something, um, instead of just like some garbage value possibly. If you don't reference if you don't initialize a pointer, that would throw an error, I'm pretty sure. I'm not entirely sure at the moment, but I'm like 80% sure. Point is, you always want your pointer pointing to something. And when you don't know what to point it to yet, you can just point it to no pointer. Or like, I mean, you saw it in the linked list when you had a pointer, because you always had, even you at the tail, you had next, but there's nothing, of course, after the tail, you would need to set next to no pointer. So that's a good example. Um, like I mentioned earlier, not all pointers are pointing to dynamically allocated memory. So make sure that you are able. So for example, like here, like this is not pointing, this pointer right here is a great example of a pointer just pointing to something on the stack and not pointing to something on the heap. So when being able to recognize that is a important thing. So building C++, um, so what's the preprocessor directive? Um, so yeah, like it's basically the part of your code that will call everything that is needed for your compiler. So that means like include IOStream using namespace std, include vector, include string, like all that. Like a stream, that's all going to be in your preprocessor. And then everything, all your actual code, is going to be in your compiler. That's a big thing. And then the last part of your executable is your linking, which is basically your linker, which is basically going to be when, like, it's basically mean your terminal. It's linking everything together. Um, Trying to think. So the biggest thing a part of like building C++ is, when it comes to like the test material, is just being able to like look through blocks of code and um, be able to work out what's going on with them. So you can, what I 100% recommend for this, and I get it, it's like kind of annoying, um, is just getting a piece of paper and drawing it out. Like literally just writing everything out, because just doing it in your head, I don't, if you're great like that, I mean, that's great, but I don't think it's worth it to find out on this exam if you're great at that. Just having a piece of paper and like, let's say you got, here I can transition to, let me pull up a whiteboard. Okay. Can y'all see my screen? Can you guys see my screen? My whiteboard?
Yep, we can see it.
Okay, cool. Just want to make sure. Okay. So, for example, like let's say you got I don't know, some for loop. For loops are, I feel like, very well loved by this course. No, stop letting me edit it. Okay. So like let's say you got like let's say you get presented with something like this, just some for loop. What I would recommend doing is just okay, you got first starting with zero. You know, I is equal to zero. And I is still less than, and because it's zero, like here, I'm gonna do this. Um, you got, oh, goodness. I'm just gonna say R for result. That's gonna equal zero. And you know, I is equal to zero, which is less than six right now. So I is gonna iterate, which makes I equal to one. So because of this, you're gonna do R plus I, which is gonna be your new R. Sorry. Okay. So right now, even though like I will be iterated, it's still just equal to zero. So you got R equals zero plus zero, which equals zero. So now you got, but now since you have I equals one, you have R equals zero. I equals one, which is still less than six. And now I plus plus equals two. So now you have R plus I equals R. And now you have R equals 0 plus 1, which is going to equal 1. So you got this. Then you move on, and it's the same process over and over. So if I did this in total, I'll just like work it out right now. Um, 1, 2. So because 5 is the last value that's going to be less than 6, because 6 is equal to 6, um, this will be the last iteration. Now you got 10 plus 5 equals 15. So I understand this seems kind of tedious, and you don't necessarily need to do this for like these like smaller functions if you really just don't need to. But this was just to show like what I was talking about, like basically drawing things out. So if you got return result is going to equal 15. Okay. That's the biggest thing. Um, yes. So back to the review. Okay. So that's my biggest recommendation when it comes to like any kind of C++ question or just any like block of code question, just draw it out. Even though that was a really simple function, I was just trying to get the idea across of like what you could do. Because that's a really simple function, but you'll definitely be encountering some pretty big blocks of code. But that's not a big deal. It's something you guys can definitely accomplish. Just make sure when you look at a big block of code, don't get overwhelmed. No, okay, let me just start drawing this out. And then you start doing it, and it'll become all the more or less overwhelming. Um, Also, a question, and I guess another like question that one of you guys could answer is what is a function that has a return type and a name and even a parameter list, but doesn't have a definition? It's okay if you guys don't know this one. Okay, so basically, a function of that description would be a prototype. So just keep that in mind, the little thing to keep in mind. And then command line compiling. So command line compiling is when you like basically just like go through experiments. Um, so command line compiling is basically just going to be um, when you're working with, how do I explain this? Like when you're working in the terminal and redirecting your directories and stuff like that. That's a big thing. So for example, like you're gonna always use you're like in this class, you're generally almost always just gonna use ls and cd. CD will move you to a different directory. So basically, let's say you have like project one and you wanna get in your terminal, you wanna get to your, I don't know, like your main CPP. You're gonna do cd main, like something like that. Um, But if you want to see everything that's in your, all the files that's in your project one, you're going to do ls. That's going to list. Um, and something that's really important to know with command line compiling is with making a make file. Sometimes like our projects get so big that it doesn't make sense to just constantly keep going through like CD and LS, like it just becomes too much. So at that point, you do something called making a make file, which in which you basically kind of just put it all into one file. Um, and it compiles code from there within the directory. So I don't know why it's not on here. I guess I must have left it out or skipped over it somehow. But wait, let me see if because I'm pretty sure there's a part about data structures, but I can't remember. Was there a part, did y'all see a part on the review, like the study guide about data structures? Because I cannot remember. Oh, okay, besides that, I will just go over it just to make sure I'm doing this about. Um, you need to know how a linked list works. You could be asked a question about like, oh, look at this function, sorry, like look at this class or function, like what's going to be the output, and it could be like a linked list function or something with like a stack or a queue. So you don't need to know like, I don't know, like you're not going to be asked like specifics about like project one if that's what you're asking, but you could be asked about like, oh, look at this block of code and it's like clearly building a linked list. Okay, I'm so sorry. I don't know why it's not in here. Okay, well, let me look at it just so I can go over that. I'm so sorry about that. Um, okay, there's data structures. With data structures, stack, it's a type of data structure, and the way it works in is first in, last out, FILO, philo, however you want to. Here, let me just start writing it. I'm so sorry. I feel so silly right now. I don't know how I missed that. Okay, stack, data structure, breaks on first in, last out, or philo, or FILO, however you want to think of it. Q, it's another kind of data structure. Um, operates on first in, first out, or FIFO, or FIFO. Um, so a good example to think of when you want to think of these things is a stack would be like a stack of plates, like, the first one you put in is the last one you're going to take out when you go to use it. And a queue is just like, think about a line. When you get in line, if you're the first person in line, you're the first one out. But if you're the last one in, you're going to be the last one out relative to each other. And then a linked list. Um, a linked list is another type of data structure. Um, with nodes linked to each other, typically dynamically allocated because of how big it is, and can be resized and um, altered. It's not no random memory access. So, for example, like array, you can like access an array like five, I don't know, but you cannot with a linked list because linked lists only know their nodes in context to each other. So it can only ever find itself through traversing through itself. I mean, yeah, like stack is also like last in for first out. It really is just that's just a different way of thinking about it. It's still the same thing. So like a stack, when you have the first thing that comes in is going to be the last thing out, and so therefore that means the last thing in is going to be the first thing out. Same thing here. Last in, last out. Does that make sense? Okay, awesome. So yeah, that's the biggest thing with the linked list is knowing that it's not memory that just can be randomly accessed. Okay. And as for hmm, so like arrays are fixed. That's a that's probably like the biggest difference. Are example, if an array size equals five, will always be five. That's unchanging. Um, and but it's also fast access. So like you can just like on like a linked list where you have to traverse the lot and you can just access an array with like I don't know, let's say like array zero kind of equal it's gonna be equaling like let's say you wanted to like it puts out five but that's what you assigned the head of the array to be. It's easy to access like certain data in the array. However, with a dynamic array or like a vector, the size is flexible. Um, and so like a linked list, it handles corrections. It just like automatically memory like manages memory. So like with a linked list, you have to like manually call new and all that, but you don't have to do that with a vector necessarily. Um, also, like an array, it can allow for fast access. So, like mentioned here, like shown there, um, which is like not something you can do with the linked list. But yeah, like the biggest difference is you can you can adjust the size. It's flexible compared to an array which is not flexible. It will never change. So that's the biggest thing with that. Um, some examples of like questions like you could possibly encounter are um, like what is the sorry, by what operation does stack work? Does it work in by first in, first out, or first in, last out? So it works in by first in, last out, or last in, first out, either or. Um, and then like the same thing could apply to a queue. You could be asked anything about a queue. Um, oh, and also keep in mind, like stacks and queues can be constructed by either using an array or a linked list or a vector possibly. So that's something to keep in mind. Um, you might be asked a question about like you might be given a block of code and asked like, hey, what is this output? And it could be a block of code that looks exactly like your linked list project. So make sure you understand, like I recommend like going back and just like re-looking back at your linked list project and really like understand like what's going on, like how things are pointing to each other, how they're getting the data so that you can, when you encounter a question like that, you can properly answer it. So yeah, those are the biggest things on the exam. Um, I definitely recommend. I think you're going to benefit the most from understanding memory allocation well and building C++ well. And also, of course, like everything in between. But I think those are going to be your heavy hitters. Um, Still study the other stuff. I'm not saying don't, but like those were most of the questions I came across that they were in that area. So that really wraps up the review. Do you guys have any questions about what I talked about? Do you guys want to go over anything else? Oh, no, binary IO it will not be. It should not be. Just in code output. Um, what do you mean by that? Like practicing, like just like coding questions? Like questions that like, are you asking me like, oh, like, do you recommend any sites that could be useful in practicing like code output questions where like you're getting a question of a block of code? Yeah, okay. If I'm being completely honest, I wouldn't there I haven't seen any kind of midterm practice test, so I don't believe there is. Um maybe I don't think I missed anything on that. I think I saw everything pretty well, but there shouldn't be a midterm practice test, at least to my knowledge. But keep in mind, the multiple choice questions are very similar in structure to like what your quizzes have been. So also go and review that. I recommend you reviewing your quizzes. And though Matthew, I wouldn't really have recommended this. I don't really recommend this as a resource to use all of the time. But just in this case, just going on like ChatGPT and asking, hey, can you give me a question that is like a block of a linked list, like a simple linked list function, and ask me what the output is? That's a really easy way to just random generate um, questions like that. I don't know of any sites that like actually do that, if I'm being completely honest, like at least off the top of my head, if I can go and find some, but right now, based off what you're asking, that's a good tool to use. I'm not recommending that you use ChatGPT really for like much owls because I think when you're in like these kinds of courses that you should avoid ChatGPT um and like tool AI tools like that. Um yeah. That's good. So just I would if you're looking for a resource to like generate question blocks of code that you can find the output for. I definitely recommend that as a resource, actually, even though like it's not something I'd recommend otherwise. So for sure, I think that's a good practice tool. If I find anything else, I can send it to you and I can actually just post it on the Slack. But at the moment, I don't know of anything like that. Um, I only really know of either questions that are like multiple choice or like full, like you're writing the code. Um, so ChatGPT would be like a good resource for finding that in between. So yeah. Other than that, do you have any more questions? Awesome. Okay. That's great. I hope you guys do well. Good luck on the exam. If you need anything, just reach out to me on Slack. I'm going to stop recording right now. And yeah, if you need anything more, you can reach out to me. Okay.